Welcome to part 2 of our flip notes on plastics. As always, make sure you have your fill-in-a-blank notes. And again, I really encourage you not just to rush through the video and fast forward through it so you can copy down all the fill-in-the-blanks, but look at the words around it, listen to what I have to say. A lot of this material is really important for you to have for the different labs and activities we do in class, and it's also going to be a huge part of the test. So what we want to look at in part 2 are the different types of plastics and why, well, not necessarily look at the different types of plastics, but look at why we have the different types of plastics. If you've ever noticed, if you've ever taken a look at a plastic bottle, it's going to have a code on it. And that code, let me grab a pen here. Pointer options right here. Let's go with the standard red. It'll have a code on it, and a lot of times it'll just have a plastic triangle like this. It'll have the arrows, and it'll have a number on the inside. Sometimes right below that it will have a symbol. Now sometimes you see PET here, but sometimes, sorry about the writing, it's not easy writing on this thing. But sometimes you'll have something called, well, oops, sorry about that. It'll say PET instead of PET. And what these are the symbols for the different types of plastics. When plastics were first brought about, they didn't have these symbols. But once we've got the idea that we can start recycling plastics, manufacturers had to figure out, how do we sort them? How do we figure out what type of plastic it is? Because all the plastics were slightly different depending on its use. So what the manufacturers decided to do is go with a universal coding system. So whenever you see a 1, it's a polyethylene terephthalate. So you'll see the symbol PET or PET. It means polyethylene terephthalate. And a lot of times we'll have this, but if it doesn't have this, it for sure will have this. So now you know it's number 1 plastic. 2 is your high density polyethylene. 3 is your polyvinyl chloride. Here you have your low density polyethylene. And notice all the initials. You got your low density polyethylene. Polyvinyl chloride. So on the test, when I ask you, match out polyvinyl chloride with PVC, just look at the initials. You have your low density polyethylene, your polypropylene, your polystyrene, and your other are just other types of plastics that don't fall into these above categories, or they're a combination of several of the different types of plastics. So one of the common questions I have is, why do we have different plastics? Well, we have the different plastics because they have the different uses. Here's polyethylene terephthalate. This is what it would look like. Here's the chemical makeup of it. And when you see it, it's got different qualities. One, it's clear. And these are going to be your plastic soft drink bottles. And whenever you think about it, whenever you go to the store, don't you want to see what type of soda's inside? Don't you want to see what color it is and how it looks? And so this is one of the qualities of polyethylene terephthalate. Its use is plastic bottles. You can make it pretty thin. It's clear. It's good strength. If you've ever dropped a soda bottle, I've dropped one after picking it up. Just don't open it right away. But it's got a good use. It's got its place. Now your recycled products, what can we recycle it into? Laser toner cartridges. Picnic tables, hiking boots, lumber. They can actually turn these into, I like this one right here, sweatshirts. You might be wearing a t-shirt today that came from a plastic bottle. Now your high density polyethylene, HDPE. It's going to be a little thicker. Its stiffness it's going to have a little bit more durability like that, like your milk jugs, your water jugs, juice containers. These are mostly going to be your number 2s, your high density polyethylene. So they got slightly different uses. Notice they're not as clear. You can usually see through them, but it's not necessarily going to be, it's going to be more like opaque, where you can see the color of milk through it, but it's not necessarily always going to be perfectly clear. And when you recycle them, you can make them into benches. So similar to what the last ones were, bird feeders, fly swatters. So notice that we can use them originally, but we can also recycle them into other products as well. Polyvinyl chloride, or sometimes it's just V. Have you ever heard of that before? How about PVC pipe? And that's one of the big ones that you'll see here. Actually, I have it right here. So let me back up a little bit. This is going to be versatility, ease of blending. It's really going to be strong. This is what's going to make a lot of your water pipes, your sewer pipes. You want it to be strong. You don't want one of those pipes breaking in your house. And recycled products that it can turn into: air bubble cushioning, decking, film, paneling, recycling containers. Now your low density polyethylene, bread bags. It's good to use for it. Frozen food bags. So you know these are going to be very thin, ease of processing. It's a barrier to moisture. It's not going to let moisture through, which is good if you're going to put frozen things in the freezer. You don't want to keep the moisture off it. Ease of sealing, low cost. You don't want to pay. Imagine if you had to pay a lot of money for a Ziploc bag. You don't want that. You want it to be really cheap so that you can get 30, 40 bags in a box. And these can be recycled too. It's things like flooring, tiles, shipping envelopes, garbage can liners. Now your polypropylene, it's got the double P right here. Strength, toughness, resistant to chemicals. So here we see this right here. Things like ketchup bottles. And this is one of those things where people say, but Mr. Wittun, you spelled ketchup wrong. Well, ketchup is a trademark. So you're going to see it being spelled lots of different ways. It depends on what company is producing the ketchup. Things like yogurt containers, medicine bottles. So you want them to be strong. You want them to resist chemicals, because a lot of times they'll put cleaners in this one because it is resistant to chemicals, resistant to grease, to oil. And then your polystyrene. A lot of times you'll think of these as being styrofoam. And if you remember, like coffee cups, styrofoam. And if you remember, you got the white cups. That's usually what we think of styrofoam is. Now, those cups are really, really light. But you got to remember, those cups probably are about 98%, 99% air. They blow air into it when they make it. It's this, the actual polymer is the white stuff, but it's not the air inside it, and what allows it to be insulated. And we want that insulation for things like coffee cups so we don't burn our hand when we grab it. Imagine if we put coffee into a metal cup, and if we tried holding on to it, it probably wouldn't feel that good. You'd probably drop it in your lap as a result, because it would be too hot. But I'm going to show you some cups in class. I'll show you some other things in class that are considered to be styrofoam, but yet just don't have all the air in it. So what we're going to do is we're going to look for the polystyrene symbol, number 6. Oop, wrong way, sorry about that. And then we finally have other. Other is just made up of lots of different, other plastics that aren't as common, that aren't into the first 6 categories, or a combination of the plastics. And uses: 3 and 5 gallon reusable water bottles, some citrus juice containers, some ketchup bottles. It can be recycled into other bottles, plastic lumber applications. So we're going to finish out the notes by talking about why plastics are so good. Again, we talked about lots of different reasons: that they're resistant to chemicals. They're good insulators. A lot of times if you have a screwdriver, the end of the screwdriver is made out of plastics. And that's so if you're an electrician, it resists the flow of electricity, so it's just safer for you. Can be used to store things like gasoline, household and industrial chemicals. One of the other neat things about plastics is you can make some really fine parts, some really small parts, say for watches. They're both thermal and electrical insulators. A lot of the wiring, you got the copper wiring on the inside, but the outside is plastics, and that's so you don't start fires. Outlet covers. Don't look at my outlet covers because mine are actually metal here. But they do have a GFCI, they're GFCI protected, so you don't have to worry about getting shocked. Pan handles. Can you imagine having all of your pots and pans? When I grew up, plastics weren't nearly as common, and most of our pots had metal handles. So whenever we wanted to cook, we'd have to have an oven mitt or a towel there to hold up the pot, otherwise we'd burn our hand. Nowadays, they're all plastic, so you don't have to worry about that. And again, like I alluded to earlier, they can be used to make really thin parts or fibers. Imagine taking apart a watch and seeing all the clock gears inside there that are moving around. So plastics can be used to make some very fine, intricate, detailed pieces or parts. And they're going to be a lot cheaper than metal. They're going to be lighter than metal. So that does end our notes. As always, if you have any questions about these notes, please see me in class, and I will check for understanding in class as well. Thanks, and see you on the flip side.